Hi. I'm not going to do stuff like this very often. Um, but I kind of had to. I watch a lot of YouTube, and one of the things I watch regularly every week when it comes out is Because Science, featuring Kyle Hill on the YouTube channel Because Science. Link below. This morning I woke up and went to my YouTube to find the title of today's Because Science video being Is Han Solo Wrong About Hyperspace? Now, if you haven't seen Because Science or Kyle's amazing presentations, what he generally does is he'll find elements of a movie, usually a science fiction, a Marvel movie, Star Wars, and and analyze it using real science, real statistics, real science, and his approach is multidisciplinary and very effective. He uses really good graphics. He's a great presenter, and how does the vibranium and Black Panther suit work, and what would happen if Superman punched you. They're really, really good, and they're thought provoking, and they are an amazing educational tool. And then this morning's came out. This is a subject about which I am passionate. I kind of have to address it. The question, is Han Solo wrong about hyperspace, comes from the line in A New Hope during the escape from Tatooine, where Han is explaining why it is dangerous to take a random jump through hyperspace. Without proper coordinates, you're going to bounce too close to a star or hit a supernova, and that it ended your trip real fast, wouldn't it? Pardon me. The beginning of that line is, jumping through hyperspace ain't like dusting crops, boy. Without proper coordinates, bounce too close to a star or hit a supernova. Now, Kyle did an amazing job of talking about the intensely low probability of traveling at relativistic or near relativistic speeds through the stellar density of a structure like a galaxy, and what are your odds of actually hitting a stellar phenomena or a star. And stellar density is incredibly low when it comes right down to it, and by the numbers, he shows his math, your chances of accidentally hitting a star by pointing in some direction and hitting the go button are, with a little rounding, 0%. It's perfectly safe to navigate through hyperspace randomly, just going, because you could travel the distance of the known galaxy, its known diameter, 158,000 times before you'd ever have a real chance of hitting a star. Here's why that answer's wrong. I'm going to give a brief example. I'm going to make a ridiculous statement, but say I'm a wizard in a Dungeons and Dragons type world, and I say, I am going to use magic, speak a spell, and cause a fireball to appear in the middle of my hand. Scientifically, you can evaluate most of that statement. You can take the average decibel level of the human voice and the range of frequencies over which a human voice can carry. You can calculate that effect in shock waves, which is what sound essentially is, on the local air molecules around me, how much energy my voice is putting into those air molecules because I am making them move, and what are the odds that I'm putting enough energy into that air in such a way and with such focus that I will cause plasma to coalesce in the form of a sphere, even for just an instant, at this distance from where I am speaking. You can evaluate all of that, and with a little rounding, you'll find the answer, I think, is 0%. But that ignores a third of my claim. I said I'm going to use words to intone a spell, and that my words will cause a fireball to coalesce in my hand, but I said using magic. Magic is a word derived from the ancient language for fuck your physics. Once you use a word like magic, the rest of your math might as well not exist, because magic is, in and of itself, meant to describe something other than science, other than physics. It is a metaphysical force. It exists in different laws than the rest of the universe. You can't use math or electron microscopes to clearly define magic. Although, wouldn't it be awesome if you could? There's a game world. Kyle's evaluation of Han Solo's statement from A New Hope is an excellent evaluation of 2/3 of his statement. The word that was skipped was hyperspace. Hyperspace, by its very loose and variable definition, is a dimension or plane of reality or alternate Dirac level, or it is a space other than the space that we currently occupy, not to be confused with other space, which is another thing entirely. Hyperspace is an area of existence where the laws of physics don't apply. This is used in science fiction to get past the speed of light being a limit. If you're going to engage in faster than the light travel, well, in this universe, by the laws of physics that we have, light speed's as fast as you can go, and if you're not light, you probably can't go that fast. You can get very close maybe, but you're not going that fast. And if you have mass, don't even think about it. So science fiction and science fantasy and space opera needs to have a way, if you're traveling between worlds, to travel faster than light that ignores physical laws. Warp speed, which technically that's closer to physical laws, as we're seeing that might actually be possible. But hyperspace is just, fuck your physical laws. We're going to another universe where everything works the way we want it to, and we can travel faster than the speed of light. Once you use the term hyperspace, you might as well be using the term magic. They both mean essentially the same thing. We are now using a term that means anything that you can rationally explain doesn't mean anything. Jumping through hyperspace ain't like dusting crops, boy. Without the proper calculations, you can bounce too close to a supernova or hit a star. I'm going to trust Han Solo's judgment on that one. 1. The speed of light is obviously either non-existent or much higher in hyperspace. You can travel faster than light. They do use the term faster than light in the Star Wars movies. 2. Hyperspace may have an entirely different coordinate system. Everything might be a little bit more tightly packed in hyperspace, meaning that the distance that you're measuring in real space might simply not be that much distance in hyperspace. I don't know, it's hyperspace. It might be further, it might be purple, it doesn't matter, it's hyperspace. The stellar density might be higher in hyperspace. One thing we do know about hyperspace, because it has been defined, is that hyperspace is heavily affected, if not generated, by gravity wells. Not just the well, but you can drop someone out of hyperspace by parking a heavy enough gravity generator in their path, relatively speaking. There's a class of Star Destroyers called the Interdictor that are basically a Star Destroyer built around a big gravity generator that just sits there being a mass to pull ships out of hyperspace. The gravity well is larger than the stellar object. The gravity well extends for pretty much, I don't know. It may extend way further than the star, which increases the amount of area that becomes a navigational hazard in hyperspace. There are so many amazing possibilities for why traveling through hyperspace requires a better course. Kyle makes another error in his presentation, that he used the Kessel run as a measure of distance, as though Han's stated run in the Kessel run is a static value. This is the Kessel run. It's this far. In A New Hope, Han Solo talks about how fast his ship is by saying it did the Kessel run in less than 12 parsecs. A parsec is a measurement of distance, not of speed. I have heard a number of things that have theories for why Han would use a measurement of distance when referring to his ship's speed. There is an in-canon explanation for this that I figured out years before it was in canon, and I figured it out when I was 12, because that's the kind of nerd I am. Or is that geekdom? That's a little bit of both, actually. I have a friend who insists that Han Solo was lying. Oh, it's a farm boy. It's a rube. I'm going to lie to him about it. I'm going to use a bullshit term so that just to mess with him. Here's why that doesn't work for me. 1. I'm going to use a bullshit term for spaceflight with this guy who doesn't know anything about it. Luke's a pilot. Luke's a good pilot. Luke didn't call him on it. So that's one reason that statement can't be accurate. 2. Han Solo's bullshitting about the thing that the pride and joy of his life can do? I don't think so. Han might be a braggart. Han might be a rogue. Han might be a gambler and might occasionally engage in some lying. But lie about the Falcon? I don't think so. So why would you not use the Kessel run as a solid measurement of distance? The Kessel run isn't about doing a point-to-point faster than someone else does a point-to-point. The Kessel run is a trip to an asteroid where spice is mined that lies in the middle of a series of black holes. These are incredible navigational difficulties for if you're traveling in hyperspace, or navigational difficulties no matter what. But in hyperspace, we're talking about gravity wells being the big problem with that. And those are black holes. So you have to travel a certain path to get through them. That's the Kessel run. But what if you wanted to do it faster? Well, you'd need a fast ship, but you still have a certain amount of distance that you have to travel. Or you could have an amazingly fast ship and you could cut the corners. The closer that you dip to the event horizon of those black holes, the more dangerous your trip is and the faster your ship has to be to give you the escape velocity from that area closer. Gravity has the inverse square law. So, and I'm talking about physical laws in hyperspace, which I've already talked about being BS, but if you can cut the distance in the Kessel run by having a ship fast enough to escape from the gravity well of those black holes, you can do it not just in a faster time, but a shorter distance. And in fact, the amount of distance that you travel in the Kessel Run, the shorter it is, not only talks about how fast your ship has to be, but how the balls of the captain have to be. Because you're diving at black holes to get this done. In one statement, ship that made the Kessel Run in less than 12 parsecs. 1. The ship's fast enough to escape from a series of black holes when I went really close to them. 2. I went really close to black holes. It'd be awesome if the Solo movie is actually the story of the Kessel Run, but we'll see. So, saying that I made the ship that made the Kessel Run in less than 12 parsecs implies that he's using that as a relative value. I made this trip shorter than other people, meaning other people made it longer, meaning the Kessel Run trip is a variable value, not a set number. So saying that you could travel this many Kessel Runs doesn't mean anything. That's the same thing as you can travel this many X because it's a variable. I'm extremely fond of Kyle Hill. I really enjoy Because Science, and I occasionally have my little glitches with the fact that he has to ignore certain things, like the concept of hyperspace, to have a proper scientific discussion of the conversation that he's having. But saying Han Solo was wrong because of a statement he made about hyperspace, and then basing your entire argument on real space physics and numbers, is like looking at that three-dimensional chessboard that they play on in Star Trek and having someone tell you that you can make this particular move in that chessboard and saying, I don't understand that, but I'm going to show you how you can't make that move on a regular chessboard, and therefore they're wrong. It's a different set of rules. There's, if he had couched it differently, not a problem. But Han Solo was wrong about hyperspace. Here's why he's wrong in real space. Sorry, bothered me. Had to say something about it. Had to put it up here. I'll link to that video down below. Go watch and subscribe to Because Science, because it's amazing and thought-provoking, because it made me think about this to the degree that I had to talk about it. Thank you for your time and attention. Thumbs up, thumbs down, comment, subscribe, Patreon. And I will talk to you soon.